Okay, folks, I am working off page 119 in your notes book, and at the top of that page from the last day you should have a definition of atomic number, which you need to learn, and it should say that an atomic number is the number of protons in the nucleus, and it should say mass number is the number of protons and neutrons in the nucleus. Now, you may be given a table like this, or you may be given what something looks like in the periodic table. So if we look at oxygen in the periodic table, it'll have two sets of numbers, and it looks like this. And the last day for homework, I asked you to learn, Mr. Duncan would have put it out, the sequence of numbers. So 1 hydrogen, 2 helium, 3 lithium, 4 beryllium, 5 boron, and so on. And if you know those numbers, then these numbers are the atomic number. And that's how our periodic table is arranged. It's arranged in order of atomic number. So what it means is when you look at something like this, where oxygen has 8 and 16, you now know that this is the atomic number. And you know that this is the mass number. Now, for you to work out how to fill in our tables, I use an acronym called APE MAN. And it's A is equal to P is equal to E. And what that A stands for is your atomic number. The P is equal to the number of protons, and the E is equal to the number of electrons. So if I know my atomic number down here is 8, then I know now that I have 8 protons and 8 electrons, which I can fill in my box. The other acronym that I use is the MAN part. And what the MAN is mass number minus atomic number is equal to my neutrons. So I know here that my mass number is 16, because it's always the biggest number. Take away 8 is equal to 8 neutrons. So I fill 8 in up here from this. And you go and you do that for all of the other ones that are in our table. Okay, so I'm just going to get rid of here for a second. So if we have a look at the next one down, the next one down is argon. So argon, if you see it on the periodic table, it will be 18 here and it will be 40. So you're going to do A is equal to P is equal to E. We always know atomic number is the smallest number. So it's going to be 18 is equal to 18 is equal to 18. So I fill that in my protons and my electrons, and then I do my MAN calculation. M minus A is equal to N, so mass number of 40, take away 18 gives me 22 neutrons, and I fill that in up here. Okay, so if you haven't done so already, you need to finish aluminium and phosphorus. I'm going to do calcium now because I'm going to use calcium to help us with the next part of this learning in a little while. So, calcium. On a periodic table, if you look at it, calcium looks like this. So I now know my atomic number is 20. It means I must have 20 protons and 20 electrons. So I fill in 20 and 20. And my MAN calculation, mass number of 40 minus 20 atomic number is equal to 20 neutrons. And I fill in my 20 here. So we're going to use that in a little while to finish what we're going to show you now. So your homework is going to be to fill in page 120 and page 121. To do that though, we need to look at this on page 121. So this is the periodic table, and what we are trying to do is we're trying to write what is called the electron configuration. And all this is, and you can write this at the top of page 121, just under the box. Electron configuration is the arrangement of electrons around the nucleus. Okay, that arrangement is going to be a set of numbers, and you're going to put these set of numbers into the electrons from each set of numbers into the electron shells. So the first thing the one that we're going to look at is we're going to look at calcium. Now, If you look at each row in your periodic table, it tells you how many electrons are in each shell. So in row 1, if you look, I've got 1, 2 here. So I write 2 here. If I go in row 2 and I start counting, I count 1, 2, 3, 4, 5, 6, 7, 8. So in row 3, I have similarly 8 if you count them all the way across. And in row 4, we're only interested in going as far as calcium. So to get to calcium, it is a 1 and a 2. What you have just done now is you have written the electron configuration for calcium. So if we are writing it, we write it as 2, 8, 8, 2. So this is the configuration of calcium. Okay, and as we've said, this set of numbers shows how electrons are arranged around the nucleus. So what does that look like? Okay, so your first shell will always contain 2, that's your first row. Your second will contain 8, your third will contain 8, and your fourth, as far as we're concerned, is going to be a maximum of 2. So we're going to look at calcium now. And we've just worked out the electron configuration of calcium is the 2882. So we're also going to use the APE MAN from earlier, and earlier we learned that there was 20 protons. We also learned that there was 20 neutrons, and we learned that there was 20 electrons. And I'm going to come back to that in a second. So how do we draw what is called a Bohr diagram using all this information? So we say 20p, we say 20n, and we put a circle around it. Now this circle is our nucleus. Okay, so the circle is the nucleus. We're now going to have to draw the shells for calcium. So our first shell is going to have 2 electrons in it from our 2882. Our second shell is going to have 8 electrons in it. And our third shell is going to have 8. And our final shell is going to have 2. This is having a freak out, but we'll get there. Now, if you notice, I'm pairing the electrons all the time, and the reason you do that is it makes it much easier to count. So this is what's called a Bohr diagram. And any chemist that looks at this would know straight away that this is a Bohr diagram for calcium. So the white is the nucleus, the red, these are our shells, our electron shells. There is a check that you can do. Have I done this electron configuration right? So we know that we have 20 electrons in total. So 2 plus 8 plus 8 plus 2 works out to be 20. So that means that that electron configuration is right. Now, your homework is going to be page 120 and 121, seeing can you write electron configurations for everything. To help you, I am going to ignore this one now, but I'm going to do the original. So on page 121, this is what we're going to look at. So on page 121, it says tri. It says lithium. It has written APE MAN. It has written electron configuration. And it has written drawing. So you have to find lithium on your periodic table. When you look at lithium on your periodic table, it looks like this. So if I'm doing my APE MAN, A is equal to P is equal to E, I have to recognize that this is my atomic number. So 3 is equal to 3 is equal to 3. I do my MAN portion of it. So mass minus atomic is equal to N. So you have to recognize that this number is the mass number. So it's going to be 7, take away 3 is equal to 4. So I now know for lithium that it has 3 protons, I know that it has 3 electrons, and I know that it has 4 neutrons. And I'm going to need this information from my diagram. If I go and look at my periodic table, it looks a little bit like this. Okay, so this is going to be hydrogen, this is going to be helium, and this is where lithium lives. So I now have to write my electron configuration. And I do that by looking at how many rows do I have to get to lithium. So I have to get to 2 rows, this one being the first row, and this is where this is on the second row. So I know I'm going to have 2 numbers for the electron configuration. And if my first row has 2 boxes, which is this box and this box, the beginning of my electron configuration is 2. And then to get to lithium, it's the first box in the second shell, so that's a 2, 1. Now to check, did I do my electron configuration right? 2 plus 1 is equal to 3, and lo and behold, up here I have 3 electrons, so I have done my electron configuration right. We're now going to see, can we draw the Bohr diagrams for this? So we are going to draw our nucleus first. So my nucleus now will have 3 protons and it will have 4 neutrons. I know for my electron configuration I have 2 shells. I have 2 in the first shell, so they're always put at 12 o'clock and 6 o'clock on a clock, and in my second shell I only have 1 electron. I have now drawn, this is the Bohr diagram for lithium. So that's what you're going to now be aiming for, and you need to be able to draw the Bohr diagram for the first 20 elements. So from hydrogen all the way up to calcium, that, is going to be your job, and you will be doing that over the next while. Any issues, please shout.